Okay, so now we're going to move into some more proofs. We'll do a little bit of review from last class and kind of introduce you a little bit into some more geometry stuff. So, warm up, Uno cards. I'm going to ask you guys to pause the video throughout the thing just to give you a chance to try something, then we'll go over it after. So right now I want to pause it and make sure I want you guys to try this warm up with the Uno cards, like what we did last time, okay? So pause it, try it, and then you can press play and I'll be going over it. Okay. Going over the Uno cards. So again, we're given the blue 8. Okay, so that's what we're starting with. Blue 8's given. What's the next thing we can put down? Well, next thing we can put down is a blue 4. So blue 4. And why can we put that blue 4 down? Because it's the same color, right? So that's the whole goal with these proofs, is you're constantly giving me reasons why you can do something. We need to get in the habit of thinking about that. Okay, so blue 4 is done. After the blue 4, we can put down a green 4. And why can we do that? Because it's the same number. Okay, after the green 4, we can put down a green skip because it is the same color. Okay, what do we put after that? Well, we're going to put down a red skip. And why can we do that? Because it's the same, kind of like the same number, so we'll just say same card. It's not really a number. And then next one, well, we can't put down the yellow 2, so we're going to put down a wild. And why do we put down wilds? To change the color. And what are we going to change the color to? We're going to change it to yellow. So now the color's yellow. So now, since the color's yellow, I can put down a yellow 2. Why can I put down a yellow 2? Well, same color. We chose yellow. Yellow 2 is the same color as yellow. So same color. And last but not least, the one we're trying to prove is a yellow 7. Why can I put down a yellow 7? Same color. Okay, so just like the Uno cards, we need to have a reason why we can do something, okay? So we're going to do a few more algebra things, but I want to introduce a new property. It's not on your tool one. We're just going to be using it today, but I wanted to use the inverse property because I wanted to have some Pythagorean theorem questions. So, inverse property. If you can use an inverse operation on one side of the equation, you can use it on the other without changing the equation. So just like the adding, when we add it to one side, we add to the other, same with subtracting. So what I mean by inverse is the opposites. So if I was to solve x squared equals 4, how do I get rid of a squared? I square root it. That's the inverse function. That's the opposite. Okay, so that's what I mean. So if I square root one side, I can square root the other. So then I'd have x equals 2. Okay? So that's what I mean by inverse property, and you're going to use this when we're doing the Pythagorean theorem questions, okay? The other thing I want us to look at, so make sure you have your toolbox out, right? It's the gold paper. We're going to be using it a lot today, so please make sure you have it. I told you not to lose it. I told you we're using it every class, so please pull it out. Okay, we're going to go look at it, the toolbox. So in looking at the toolbox, we're going to do another property on here. Substitution. Okay? So, substitution. We're just going to be substituting numbers, okay? So, like right here. If x equals 3, we can substitute 3 in for x. And that's what they did right here to get the answer. We're just substituting numbers in for the letters, which is what we do with the Pythagorean theorem. So that's a property. The substitution property is a new one we're talking about today, okay? And then we're using all the other ones. all these other ones that we had from last time. And the combining like terms and simplifying. Okay, so going back, I'm going to have you pause this, and I want you to do question 2, because it's exactly what we did last class. So I want you to do question 2, then we'll come back, I'll go over question 2, and then we'll go over question 3 together. So pause it right now. Okay, so for question 2, we're solving for x. So what do we need to do? We need to get rid of this -5. How do I do that? Well, I need to add to both sides. If I add to both sides, it'll get rid of that -5. So I'll just have x over 4. And then if I'm adding to the other side, 2 plus 5 equals 7. So why can I do this? Because of the addition property, right? So I'm having to give a reason why, and the reasons are in our toolbox. Now, how do I get x by itself? Well, it's x divided by 4, so we're going to need to multiply. So if I multiply, the 4 will cancel out and I'll just have x, and then 7 times 4 is 28. Reason I can do this is because of the multiplication. Multiplication property. Okay, so that's that problem. Let's go to the next one. So, assume a squared plus b squared equals c squared, and the measurement of sides A is 15 and B is 4. We're going to prove that c equals 15.5. So this is the Pythagorean theorem. So this is what we're assuming. It's given to us. Okay, so the next step is, if I have this Pythagorean theorem and I have these measurements, what should I do with those measurements? Well, I should plug them in, and that's what I did here. This was normally A, this was normally B. We put those in. What property on our toolbox says we can put numbers in the place of letters? Well, that was the substitution property. That was the substitution property that says we can do that. Okay, so now, looking right here, those are both numbers that we can add together. So that's actually, since they're both numbers, they're both like terms. So we're actually combining like terms. So we combine like terms. That's what we do when we add them together. So 15 squared plus 4 squared gives us 241. That's what happens when we add them together. Now, I need to get c by itself, but it's squared. So normally we take the square root, right? And what new thing did we learn that was? Our inverse property. So the reason we can do that is our inverse property. Okay? So those are the reasons. When we're adding things together on one side, it's combining like terms. And then we use our inverse property when we're doing square roots. Okay? So I want you to pause this, and I want you to try question 4. Okay? Try question 4. We'll go over it, but I want you to try it. Okay, going to question 4. It's just like question 3. So, question 4, we have Pythagorean theorem again, but we're given A and C and we're trying to prove B. So, whenever we're solving it, well, now I know what A is and I know what C is, so let's plug those in. So I have 4.6 squared plus B squared equals 12 squared. Why can I do that? Because of the substitution property. So substitution. That's why I could do that. Okay. Now, I'm trying to solve for B. I need to get B by itself. But I have this 4.6 squared. How do I get rid of it? Well, if I minus 4.6 squared to both sides, I can get rid of it. then that gives me b squared equals, and if I minus these, I can type that in my calculator, I get 122.84. Why could I do that? Well, I was subtracting, so it's the subtraction property. Okay, last thing, it's squared. I need to get rid of the squared. So remember, we square root both sides. Gets me b equals 11.1. So why could I do that? And that was our inverse property. Okay, so I know these were a little bit harder, but it's still just using our toolbox. So we wanted to get practice still using the algebraic terms in our toolbox. Now we're going to learn a few new definitions from our toolbox, okay? So let's go to our toolbox again. And let's look at the top. So the top of our toolbox has some definitions here. So the first one is just the equal sign right here. That's our equal sign. What's an equal sign used for? We use it to show that numbers and variables are equal to each other, the same. That's what we use it for. Then we have this new symbol here, okay? It's called congruence. It's what we use to show objects, lines, shapes, angles are the same, okay? So it's for when we show things that really aren't numbers, show that they are the same. We use the congruence symbol. Okay, and then we have some other definitions. So we have AB versus AB, and you see how it has that line on top? Then this one has an arrow, and this one has an arrow going both ways. They actually all mean different things. So let's read right here. Just the AB is used to indicate the length of a segment with endpoints A and B. AB with a line on it is a line segment. AB with a line going one way is a ray. And AB with the arrows going in both directions is a line. Because a line actually looks like this and it goes infinite in both directions. So that's why we have arrows, okay? So remember, I said you can have this on your test. So you will have these definitions with you. You can use this toolbox whenever you see these symbols. Be like, oh, I don't remember what this is. Look at your toolbox. Okay, there's a few more. So this symbol right here is just to name an angle. So for example, if I had a triangle and one of the angles was A, I call it angle A. That's what I would do. If we have a little M in front, that's to show the measure of the angle. So I'm actually giving a measurement, so like 70 degrees. So sometimes how we see it, as we'll see it, is the measurement of angle A equals 60 degrees. So it's when we're actually getting an actual number. Another symbol that's not on here, but I want you to know, is if you see a triangle and say ABC, that's just naming a triangle that has the sides A, B, and C. Okay? Pretty straightforward. Last ones. If you see these two lines next to each other, that indicates that two lines are parallel. And this one where it's an upside down T, that symbol indicates that two lines are perpendicular. So remember, they come at each other at right angles. Okay? So these are words you're familiar with. We're just reintroducing the symbols. So like I said, use this toolbox as notes throughout this whole unit. If you don't remember what something means, look at it, okay? So you're going to use these. So, going here, it's matching. These are all the definitions we just talked about. I want to give you a second to match them. You literally have the answers right in front of you because you have your toolbox. but I want you to pause the video and try to match them, and then I'll show you the answers for it. So go ahead and do that. Pause the video. Okay, so coming back, the answers were B, F, H, K, E, J, A, G, D, I, and C. Okay, so you can match those up. You can see. I won't really go over why, because you can literally see the definitions in your toolbox, okay? But I just want us to kind of get familiar with them, because these definitions will help us when we make our two tables for our proofs. So we're going to practice using these definitions in sentences, okay? So, again, what does it mean when I have the arrows pointing both directions? What is that again? Well, it means it's a line, right? You can kind of see right there. So this is telling me I have a line AB. So let's write that. So line AB, that's what this is saying. So we're just interpreting the symbols. This is kind of like when someone has to interpret emojis from a text, or just slang, text message slang. This is exactly like that. We're just using math symbols instead of emojis. Okay? So we're just interpreting the symbols. So this symbol again is perpendicular, right? You can see that. Where's I? Right there. So line AB is perpendicular. And what is it perpendicular to? Line CD. That's it. Line AB is perpendicular to line CD. So let's try this next one. Again, we're just interpreting it. So if we remember what this means, it's the measurement of angle D. So the measurement of angle D, and we know what that is, it's just equal to, is equal to the measurement of angle H. Okay, so that's all we're doing. So now we're going to go the opposite direction. We actually get to write the symbols. So like we're actually typing the emojis. Okay, so line segments. So you remember what we do for line segments? So remember right here, line segments. So line segments have just that straight line over it. So line segments M and N are parallel. So I got line segment M. But what was the symbol for parallel? Well, that was the two lines, right? So they are parallel to each other. Okay, next one. We're going to read it. It says the measurement of angle A and B. So remember when we have measurements, that's the one with the M. So measurement of angle A and the measurement of angle B are equal to the measurements of angle C and D. Okay, so we're just interpreting and putting our symbols. Okay, so again, use that toolbox to help you know and remember your symbols. We're going to be using them almost every single day for the rest of the month and into March. Okay, so this is the main stuff I wanted us to go over today, is I want us to know the symbols and I want us to review using our toolbox. Eventually, you guys are going to be doing stuff like this. So I just wanted to introduce you and show you an example of a geometric proof. Now that you know what some of these symbols mean. So, I want us to grade this proof on a scale of 1 to 5, 1 being ineffective, 5 being extremely effective. So let's read through it. So D is the midpoint. Midpoint literally means middle of, you remember what this means? Line segment AC. So that's this right here, line segment A to C. Okay. I think that's a typo. That should be AB, sorry. So, line segment AB. And you have that symbol right there. Remember that was congruent, so same as angle CB, or line segment BC. So they're the same, okay? Same length, same everything. They're exactly the same. That's what that's telling us. We have to prove that the triangle ABD, so ABD, is the same as CBD. So these two little triangles are the same, okay? So this is an example of something that we are going to be working towards you being able to do. So just wanted you to see it before we start moving into it. So, remember these two statements are given to us. D is the midpoint. Line segment AB is congruent to line segment CB. Those are given to us. The next statement, if we were to prove it, is to say the line segment AD is congruent the same as CD because of the definition of midpoint. Really, what's that saying? If I stuck something exactly in the middle, would the measurements on both sides be the same? Yeah, you're putting it exactly in the middle, so the measurements on both sides are going to be the same. Since they're the same, so they're going to be the same. The next one is saying that this middle line for both, it's like it equals each other, right? It's not going to change. That side length that line is going to be the same no matter which triangle it is. And then the last one, therefore, since every single side length is the same, they're congruent because of the, and this might ring a bell. You remember this side, congruence proof. So because of side, they're the same. Okay? So I know this might look a little confusing and a lot, but this is what you guys are going to be working up towards. Okay? And we're going to have a lot of practice with this, but I just wanted to introduce it to you. So we're going to do one that's a little bit easier. We're going to prove the measurement of an angle. Okay? So if we look, we have our triangle. We have our triangle N, L, and M. It tells us that the measurement of N is 42 and the measurement of L is 116. I know you guys know how to find M, right? So let's just go through the proof, the reasonings why, okay? So, this is what's given to us, right? We're always given something at the beginning. We're told the measurements of angle N and L. Okay. Well, what do we know about a triangle and their angle measurements? We talked about this before the test. All the angles in a triangle add up to what? 180 degrees. That's the reason. That's a reason. Okay? So the reason we're adding all of these, and oh, here's another typo. This should be M. This should be M. Sorry, there's a lot of typos here. There we go. Okay. So the reason we can add all those together is we know the angles of a triangle add up to 100 degrees, so 180 degrees. So we can write that. All angles in a triangle add up to 180 degrees. We know that rule, okay? That's something we know. Okay. Now, because we actually know the measurements of N and L, we plug those in. What in our toolbox allows us to do that? Substitution. Okay. So now, are those like terms? Yeah, we can add them together. So if we add them together, we're combining like terms. Okay, and the last thing, how can I solve for it? Well, we can minus 158 to both sides. So, subtraction property. Okay, so we can still use our algebraic terms, and we're going to be using our toolbox to do the same things we were doing with the Uno cards and the algebraic expressions. But like I said, we're going to get a lot of practice with the trigonometry. It'll be okay. But I just wanted to introduce you to what everything's going to look like, okay? So now you can go ahead and work on that homework assignment.